Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from Secondary Surveillance Radar chapter from the resource called Ground Studies for Pilots by R.V. Underdown. So there are some 8-9 questions. We will answer all the questions one by one and this will ensure more practice. I have already answered questions from Oxford Radio Nav book, Keith Williams, and now this. So let's start. What SSR code would you select on mode A? Okay, on mode A, if you were entering UK airspace from overseas, okay, and had not been allocated a specific code. So we have done this many times. If you are entering UK airspace from any outside airspace where no transponder code was given to you, you are going to set 2000 in your transponder. You are going to set a transponder code 2000, and this will give an idea to the air traffic controller that you are that particular aircraft who is not with any transponder code. Okay, so 2000. Question number 2. The P2 signal of an SSR interrogation is stronger than what? Is stronger than the mode A pulses, comes after the mode A pulses, is stronger than mode A side lobe, comes after mode A side lobe. So very important question. Now understand, let's say this is your aircraft. Here is your secondary surveillance radar on the ground, and here is your aircraft. Now this secondary surveillance radar will transmit a radio beam, okay, a radar transmission in the direction of this aircraft. Interrogation pulse in the direction of this aircraft. But every radar transmission will have some amount of energy getting distributed, getting lost, wasted, or spilled, okay, spilled outside in the form of or through side loops, something called side loops. Okay, so this is the main direction in which radar transmission or in which radar energy is getting directed, and these are the side loops. Side loops dissipate or waste radar transmission energy. Okay, now there it may happen that this aircraft, instead of replying, okay, replying or transponding to this main direction beam of radar transmission, it replies or transponds to the side loops. So if this happens, there will be inefficiency, okay, or there will be what? Interference of unnecessary responses with useful responses. Okay, remember this point. Now how to avoid this or how to prevent this from happening? So what we do is, now in case of mode A, we have two main pulses, P1. P2 is not the main pulse, but still I'm writing here, I will explain it, and P3. So P1 and P3 pulses are belong to mode A, belong to mode A. Now how? Similarly, in case of mode C, we have P1, P2 and P3 pulses. P1, P2 and P3. Now in case of mode A, the distance between P1 and P3 pulse is 8 microseconds. In case of mode C, the difference or the distance between P1 pulse and the last pulse is 21 microseconds. Now in both modes, there is pulse number 2. Pulse number 2. Now this pulse number 2 is transmitted in addition to pulse number 1 and pulse number 3 to prevent this from happening, to prevent this interference of side lobes happening. So what happens is, I will take a new slide. A P2 pulse, make note of this, a P2 pulse is transmitted 2 microseconds after 2 microseconds after the interrogation pulse. So the distance between P1 pulse and P2 is 2 microseconds. Next important point is that this control pulse, that is P2 pulse, is weaker than the interrogation pulse. Than the interrogation pulse. Next, third point, aircraft transponder receives three pulses: pulse 1, pulse 2, and pulse 3. P2 pulse is weaker than the first pulse, that is P1 pulse. Transponder will come to know it is receiving the main interrogation beam. The main interrogation beam. Okay, the main interrogation beam. And it will respond successfully, like normally it will, and it responds to that interrogation beam. If the second pulse, P2 pulse, is stronger than P1 pulse, it knows is outside the main beam and does not respond. So it will come to know that actually what it is receiving is the side lobes, not the main interrogation beam, and does not respond. So remember this. Okay. So the correct answer here will be the P2 signal of an SSR interrogation is stronger than mode A pulse. No. Comes after mode A pulse. Yes. So correct answer is option Bravo. So it comes after the mode A pulse P1. Okay. And stronger than mode A side lobe comes after mode A side lobe, irrelevant. So question 2 is Bravo. Next, which of the following is untrue? Mode S addresses individual aircraft. Yes. The S in mode S stands for selective. So it will address individual aircraft, unique aircraft, one aircraft at a time. Mode S allows more accurate height readout than Mode C, yes. In case of Mode C, height readouts happen in increments of 100 feet and the accuracy level is plus minus 50 feet. In case of Mode S, height readouts happen in the increments of 50 feet and the accuracy is plus minus 25 feet. Okay. Mode S uses twice as many codes as Mode A or Mode C. That is wrong. In case of Mode A, we have 4096 possible codes. In case of Mode S, we have much more than the twice of that amount or twice of that value. We have 1.6 crore codes. Okay, so it is more than the twice of this 4096 value. Mode S can be used together with Mode A and Mode CS. Mode S has the capability to answer to interrogations of Mode A and Mode C as well. Next, question 4. Which of the following isn't an advantage of secondary radar over primary radar? So, ground returns are eliminated, yes. Now, what are ground returns? Now, primary radar makes the use of echo principle. Primary radar makes the use of echo principle in its operation, meaning there will be aircraft in the atmosphere. The primary radar is going to send a radar transmission in the direction of that aircraft. In the direction of that aircraft, this radar transmission will go to that aircraft target, strike that aircraft target, and get reflected back, get reflected from it. This everything will happen at a particular fixed frequency f. But in case of secondary radar does not make the use of echo principle. Secondary radar uses two different frequencies. One frequency for interrogation and another for reply. Different frequencies are used. Okay, so interrogation pulse is at 1030 megahertz, reply pulse is at 1090 megahertz. Since it doesn't make the use of echo principle, it uses two different frequencies, one for transmission, one for reception. So it is going to receive only that frequencies which will be at 1090 megahertz. That is going to be sent by aircraft transponder only. So any reflection coming from the ground will be disregarded. So that is one advantage of secondary radar. But in case of primary radar, it will keep getting ground returns. It will get returns from aircraft, mountains, other reflections from other objects also. So that is a disadvantage of primary radar. Next. Next option Bravo states every aircraft within range paints on the screen. The target aircraft identifies itself. This is right. In case of secondary radar, the ATC controller will get to see the aircraft identification registration on his controller screen. So along with aircraft identification, the transponder will also transmit information like flight level, wake turbulence category, ground speed, right? So that is one advantage. But in case of primary radar, the ATC controller will only get to see the representation of aircraft in the sky. That is the radar blip. But it will not have any specific information with respect to that particular aircraft, its aircraft ID, flight level, speed, etc. Power required by the transmitter is reduced considerably. This is another advantage. In case of primary radar, in case of primary radar, In order to double the range, you need to multiply the transmitter power by 16 times. But in case of secondary radar, if you want to double the range, achievable range, you must multiply the transmitter power four times, only four times. Because in case of primary radar, you are going to use one frequency throughout the cycle. In case of secondary radar, you are going to use one frequency for transmission, another for reception. So the power required gets diminished. So this is an advantage. So what the disadvantage is that every aircraft within range paints on the screen. In case of secondary radar, your aircraft must have a transponder on board. It must have a particular airborne equipment called transponder on board. Only and only then the secondary radar will be able to detect that aircraft and represent it on the screen of ATC controller. Okay, so every aircraft within range, no. If there are any aircraft which do not have transponders, they won't be detected by secondary radar. They will still be detected by primary radar, but not secondary radar. So every aircraft, no. Only that aircraft with transponders will be spotted, detected. Question 5. Your aircraft is being hijacked. What code should you select in your transponder? So the code to be selected is 7500 for hijack. Radio failure, it is 7600. For transponder failure, it is 0000. For distress, it is 7700. Next, question 6. Why are SSR transmissions in pairs of pulses? Right? So it transmits radio energy in the form of pulses. Pulses are nothing but bursts of energy, packets of energy. So to prevent random noise being falsely identified, to provide side lobe suppression, to indicate the mode of interrogation, to avoid dividing the response time by 2 to find out the range. So correct option here is Charlie, to indicate the mode of interrogation. So mode A transmits pulses, three pulses, pulse 1, pulse 2, and then pulse 3. So pulse 1 and pulse 3 are separated by 8 microseconds. In case of mode C, pulse 1, pulse 2, pulse 3. So they are separated by 21 microseconds. So this is how you differentiate between mode A and mode C by the distance between the pair of pulses. Next, 7. How many codes are available in mode A SSR? So simple, 4096 codes. In case of mode S, available codes are 1.6 crore of 16 million. Next, what does special position indicator facility of an SSR do? So special position indicator. So special position indicator is nothing but in your aircraft transponder, in your aircraft transponder, there is a button called ident button. This. Now, whenever ATC wants to identify your position on the radar screen, because on ATC's radar controller, there will be many aircraft representations on his screen. This. Now, let's say you want to receive or you want to make use of ATC radar facility. You want to obtain ATC facilities, services, radar vectoring. So, you will first have to identify yourself, okay? And ATC controller will have to locate your aircraft, the position of your aircraft on his screen. Now on his screen there will be multiple aircraft. Now out of those many aircraft, he has to identify or he has to find out or figure out one particular radar representation that belongs to your aircraft position. So one way to find that out is by pressing the ident button on your transponder. When you press this ident button, the radar representation or the radar blip belonging to your aircraft will flash on ATC radar screen for 20 seconds. So that is how ATC controller will come to know about your aircraft position. When you press the ident button on your transponder, there will be an additional pulse called special position identification pulse sent to the ATC controller system. Okay, whenever your transponder replies to interrogation pulses transmitted by SSR radar, it sends two framing pulses F1 and F2, and between them there are 12 other pulses. So along with them, there will be another special ident pulse called special position identification pulse, transmitted 4.35 microseconds after framing pulse 2, after that, to the ATC controller system. Okay, and when that happens, the ATC will come to know about your position in the sky. So the correct option here will be, it sends an extra pulse for 20 seconds, yes. It switches mode A response on and off. It sends extra pulse for 1 minute. It switches the mode A response on and off for 1 minute. So answer is, it sends an extra pulse 4.35 microseconds after the main pulse, main framing pulse for 20 seconds. Right? So very important. Mode C gives indications to the ground about aircraft ka altitude. If the indications are more than a certain amount in error, it must be switched off. What are the limits? So remember, in Oxford it is given plus minus 300 feet. In this particular book, Ground Studies for Pilots by R.B. Underdown, it is given plus minus 200 feet. In exam, select 300 feet. Now, the transponder mode C capability, transmit your altitude information with respect to 1013 millibar. Okay, this will be irrespective of altimeter pressure setting. Okay, so your altimeter pressure setting may be set to local QNH, but irrespective of that, the altitude information transmitted by transponder mode C will be with respect to 1013 pressure data. Next thing, now this is the altitude transmitted by transponder. Next, ATC controller may also ask the pilot to report his altitude or flight level that is flying. Okay. Now, if the altitude or flight level reported by pilot, okay, whatever that is, if the difference between the altitude reported by the pilot and the altitude or flight level reported by transponder or transmitted by transponder, if the difference between these values is more than or less than 300 feet, plus minus 300 feet, then ATC controller will ask you to switch off mode C capability of your transponder. Okay, it must be switched off if the limits are plus minus 300 feet. So this answer is correct, plus minus 300 feet as given in Oxford book. So this concludes our lecture for secondary surveillance radar from the ground studies for pilot textbook by R.B. Underdown. Even if you don't have that textbook, no issue. I'm going to solve all the questions from that textbook, and the explanations that I give are consolidated in consolidated form from Oxford, GST, Ground Studies for Pilots, Keith Williams. So if you listen to my explanations, indirectly your theoretical understanding from this book, Ground Studies for Pilots, will be done. So I wish you all the best. I suggest you all practice these questions many times. Oxford, Keith Williams, R.K. Bali. Read the chapters, mark the important points. I have uploaded a lecture in which I have marked important points from this chapter, and so do watch that video, write those important points, revise them. I request you all to share this video with your friends, subscribe to this channel if you haven't yet, and share this video with your correction and hit the like button if you have liked this video lecture. Thank you for your time.